Quantum and Blockchain Convergence.
Good morning, everyone. Thank you so much, Olga, for having me here. I hope you all are having a good time in Manila. Thank you for joining in. Today, as Olga mentioned, I'm going to talk about the convergence of three very powerful forces, and I'm going to pay more importance to two of them, blockchain and quantum computing. A reference point. Recently, you would have heard that BlackRock made its ETF filings where they specifically mention that quantum computing is the biggest threat to Bitcoin ETFs. That's where we are going to start diving deeper into. Why does that statement come out in a legal filing? Why is it that bigger organizations today are starting to pay more and more importance to the convergence of quantum and blockchain? That's what we're going to talk about today. Who am I and why you should listen to me? I've been in this space since 2016, 4 times founder, now building a quantum proof blockchain. And rest of the details are here, but more importantly, about the topic today. Blockchain industry, as we speak today, is more than $3 trillion of cryptocurrencies which is floating on the blockchain network. More than 3 trillion with a T. Quantum computing, the investments in that space has been increasing consistently over the last couple of years. Why is it important to look at these two industries coming together? Now for that, we have to understand how do the technology of quantum computing work? How does the security of blockchain works? Now, before even I jump into the quantum aspects, let's very foundationally understand what keeps your money on blockchain secure. Those $3 trillion that we spoke about, which is floating on the blockchain networks, what is keeping it secure? We have all heard your private keys, your money. Not your private keys, not your crypto. What does that mean? Simply speaking, if person A makes a transaction and makes a transfer of crypto to person B, what happens is the public key of person A and person B is flashed on the network. They interact with each other, as the name suggests. But the public key is linked with the private key of the owner as well. But this linkage is secured by ECDSA, elliptic curve digital signature algorithm. This is what ensures that even if somebody has access to your public key, they cannot reverse engineer and get access to your private key. And your money is secure. And then you can transact as much as you want, however you want, on the blockchain network. So fundamentally speaking, this ECDSA is the security encryption that keeps your money secure. Now, how does ECDSA work? What is so confident about ECDSA that we are able to trust $3 trillion on this one encryption? ECDSA is nothing but the mathematical factorization of two very large numbers. It's a multiplication of two very large numbers, solving which requires immense computation power. The computers today don't have that much of computation power, and hence it is secure. Let's park it at that. Let that sink in. Okay? Comes quantum computers. What is quantum computer? As the name suggests, it uses quantum bits, qubits. Our classical computers are binary, 0 or 1. Qubits, 0 or 1 or a combination of both, which gives them million times more processing powers than our current classical computers, which means they can solve the same problem that classical computers cannot solve within seconds. So is quantum the only risk? No. Quantum is the most peak of the risk that you can expect. GPUs, we are in a gaming conference right now. GPUs are used the most to play games. What is GPUs? What does GPU provide you with? Computation strength. That's why your games work more fine. That's why your games work more fluently. Any additional computation strength makes the current encryption weaker because it provides the ability to solve the mathematical calculation that is ECDSA. And that's the most important thing to understand. Now let's understand what kind of threats can exist if a quantum computer comes to life. If you see this diagram on the screen right now, we have tried to explain how does this encryption work and how can somebody decrypt it. I'm going to simplify it for you guys. Like I explained, if I send you money, my public key interacts with your public key, and if somebody gets access to that public key, using a quantum computer, you can reverse engineer, solve ECDSA calculation, and get access to somebody's private key, and that gives you access to somebody's wallet. That's the threat that we are living in right now. ECDSA was invented 40 years back, 4 decades. We are still using the same encryption. And that is a problem that needs to be solved. What is the solution? Post-Quantum Cryptography. This is the term which has been initiated by NIST, National Institute of Standards and Technology. This is an institute which authorizes any algorithm that is allowed to be used publicly. Now, post-quantum cryptography, as the name suggests, is prepared for the quantum era. Now, these are the encryptions which removes the element of mathematics from a security encryption, which allows even a powerful computer to not have the ability to solve the math and then get access to your private keys. That's the era that we are getting into. Is it actually very serious? Should we start taking it seriously? Don't we have enough time? We have heard that quantum computers are decades away, etc., 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 right? Now, recently, NIST released a formal paper where it was mentioned by 2030, 5 years from now, ECDSA will be discontinued. This is the current encryption that all of us are using. If any money you are sending to anybody, what keeps your money secure is ECDSA. To be discontinued in 5 years. What does that mean? You have to start the transition today. You have to start building post-quantum cryptography-based solutions today. US passed a bill, if I'm not wrong, in 2019 or 2020, which mandated that if you have to do any business with the government bodies of US, you have to use post-quantum cryptography. You cannot engage in any kind of a business with a government body of US if you are using pre-quantum cryptography. That signals something, right? And that's the amount of seriousness that this topic revolves around. Are governments doing something in this direction? Answer is yes. From US to Switzerland to Singapore to India, Germany, China, UAE, across the globe, there are billions of dollars worth of investments being made in 2 places. Number 1, to develop quantum computing capabilities. It's very important that the computing strength of today's age consistently keeps on increasing. And number 2, at the same time, create solutions, make developments in the direction of creating post-quantum cryptography-based solutions. Even in the age of blockchain, even in the age of crypto, in the next 5 years, I strongly believe that all the existing blockchains will have no option but to switch to post-quantum cryptography. Bitcoin has this proposal, BIP 360, moving to post-quantum cryptography. Caspa, Ethereum, Solana, every big blockchain out there is working towards making themselves quantum secure. Without that, there's no existence. Now, on that note, I want to draw down attention to 2 things. Number 1 is, whenever technology advances, we always experience every decade something new or something revolutionary comes to the world which requires attention to think differently. When Bitcoin white paper was launched, it forced people to start thinking towards decentralization, towards using a public ledger which is trustless. You don't have to trust a central banking authority. Now, if you are trusting that ledger, where you are not relying on any central authority, don't you have to question how secure it is? That's how serious it is. And on that note, I would like everybody of you to just think twice next time when you make a crypto transaction. Is it secure? Is the encryption that my blockchain or my network is using is actually uncrackable? If not, think about the choice you make. Thank you very much.